Today you'll be learning lesson 1.9 on patterns, equations, and graphs. Okay, the equations you're going to be working with today are different than the ones we worked with in lesson 1.8 because these ones are two variable equations. Okay, two variable equations are equations with two different variables. Most of the time you're going to have x and you're going to have y. These relationships will have more than one solution because what these do is create ordered pairs, okay, which are called your solutions to a two-variable equation. Okay? They're ordered pairs that give you that solution of x and y. So every time we sub in for x with one number, we're going to get a different output for y. Okay? These solutions can be represented by an equation or on a graph. When you're testing solutions to two variable equations, just like we did for single variable, you substitute for each variable. Okay, that first step is still a substitute, but now we have to plug in for x and we have to plug in for y. We then evaluate both sides of the equations, and if it's true, it is a solution. If it's false, it is not a solution. Remember what those look like. If we get a true statement, it's going to be something like 4 equals 4. That's true. Whereas when it's false, it's something like 4 equals 2 or 4 equals negative 4. Okay? Those are both false statements. Let's try some of these. Okay, so right here I have an ordered pair. We need to remember that an ordered pair is x, comma, y. Okay, so what they're really telling me here is that x equals 5 and y equals 20. Okay, so I'm going to substitute those two numbers into that equation. So it becomes 20 equals 4 times 5. And so to check it, I just solve that math. There's nothing to solve on the left, so I leave 20, but 4 times 5 is 20, which is a true statement, meaning that it is a solution. So that ordered pair of 5, 20 is a solution to that equation. So the next one, they're actually asking us to check 4 different ordered pairs. So we need to check all 4 of those into that equation. Move this up a little bit so we have some space. Okay. So the first one they're asking me to check is the ordered pair 3, 5. So they're asking me to solve when x is 3 and when y is 5. Okay. So I'm going to plug in 5 for y. So we have 5 equals x, which is 3, plus 2. Okay, I solve that, and I end up with 5 equals 5, which is true. So the ordered pair 3, 5 is a solution. So the next ordered pair they asked me to check is 4, 6. So I'm going to plug in the 4 for x and the 6 for y. Remember, ordered pairs again are x, comma, y. So this time we end up with the equation 6 equals 4 plus 2. And if I solve that, I end up with 6 equals 6, which is a true statement. So the ordered pair 4, 6 is a solution. And you don't have to write that out as a full sentence, okay? You can just say yes or no, but the true answer is solution or not a solution. So let's look at that third one. Okay? So the third one they gave us is x equals 5 and y equals 7 from, again, taking that from that ordered pair, x comma y. So when I plug those in, 7 is supposed to equal 5 plus 2. Solve it. 7 equals 7, which is true, which means the ordered pair of 5, 7 is a solution. I'm going to check that last one. We have one left. Okay. The last ordered pair that asked me to check is 6, 8. So that x is equal to 6 and y is equal to 8. So when I plug that one in, I get 8 equals 6 plus 2. So I get 8 equals 8, which is true. So the ordered pair 6, 8, okay, is also a solution. Okay. So in this problem, all 4 of those ordered pairs were solutions to that equation. Okay? Remember, if it was ever not a solution, we would get that false statement, such as 5 equals 10, 5 equals negative 2. Okay? When that happens, it is not a solution. So this next problem we're actually going to do in 3 different ways. Okay, we're comparing tables, patterns, and graphs today. So it says, Will runs 6 laps before Megan joins him on the track. They run together at the same pace. How can you represent the relationship between the number of laps Will runs and the number of laps Megan runs in different ways? Use a table, an equation, and a graph. Okay, so right here they're giving us a table to start with. Okay, but the thing, if you have to do your own, you need to find your key pieces of information. Okay, so if I look here, it says Will run 6 laps before Megan joins him. So when she hasn't started running, he is already on his 6th lap. Okay, and then that they're running at the same pace once she joins him. Okay, so every one after 6 that she runs, he will run 1 more. Okay, so if you look at the table, and they were nice enough to start it, okay, it's a little bigger for you guys. The number of laps, okay, Megan runs is our top row, and the number of laps Will runs is our bottom row. Okay, so when she hasn't ran yet, he has done 6 laps. After she runs 1, he also runs that 1 with her, which means he is now up to 7 laps. Okay, when she does 2, he's ran that second one with her, so he's up to 8. When she does 3, he's up to 9. When she does 4, he's up to 10. Okay? And that pattern is going to continue until we get our table filled up, because they gave me this table, so this is the table I need to complete. Okay, so at 5, he runs the 11. 6, he runs 12. 7, he's ran 13. Okay? Each time they run a lap, their number is increasing by 1, but the difference is that he started with 6 laps. So there's an example of demonstrating that relationship with a table. So this is the exact same problem, just this time we're going to use an equation. Okay, so that last one was about a table. Now we're doing the second part of the problem, which is a graph, or an equation, sorry. Okay, so it says exercises 9 through 11 will help you write the equation to represent the relationship. And I'm going to make this a little bit bigger again, okay, so that we can see. Okay, we're going to say x represents the number of laps that Megan runs. And we're talking about 2 different people, so then we need y, so we're going to say y represents the number of laps, I'm going to abbreviate number, that Will runs. Okay, so x is for Megan, and y is for Will. Okay. Underline the correct word to complete the next sentence. So it says, in the relationship, y will always be greater than or less than x, Well, what we remember from that problem is that Will had already ran 6 laps before Megan joins him, which Y is talking about Will, so Will have always ran more laps, so greater than the number of laps that Megan runs. Okay, so what that means is the number of laps that Will runs is our bigger one, and when you write an equation, it's usually easiest to start with your bigger amount. Okay, so his number of laps is equal to Megan's plus the 6 he already ran. Okay, so what this really looks like is Will's laps equals Megan's laps plus those previous 6 laps. Okay, so there's an equation representing that relationship. So the easiest way to come up with the equations is always think about which one's greater or else your total, and you set that as your equals to. So the last way we have to look at this problem that it asks us to is as a graph, okay? So when I think about that, we can really think about it from our table, okay? We know that that first ordered pair, okay, the first point we have is that when it says write it corresponding to Megan arriving at the track. Well, when Megan arrives, she's ran 0 laps, but Will has already ran 6. And if you remembered ordered pairs, remember that this is X, comma, Y. Okay? So what that means is for a graph, remember your graphs, which this one's nice and they labeled it for us. This axis down here is your x-axis. This one, the vertical one, is your y-axis. So what they're telling me by that ordered pair is that x is representing Megan's laps. And that y is representing Will's laps. Okay? Whenever you do a graph, you need to make sure you label that x-axis and you label that y-axis. And the last thing we need on a graph is a title, okay? So what this is about, we don't need to say Megan and Will because those are already in our x and y axis labels. So what we need to do is come up with a title that tells us what these